Well, hello there, my dear students. You're very welcome to lecture number 7, problem set number 5 of dimensional analysis. I'm your own personal physics tutor, Dr. Rima McMullen. So our first problem for today says that in a certain system of units, all quantities can be expressed in terms of only one physical quantity, and that one physical quantity is x. Now, typically in mechanics, you know that every physical quantity can be expressed in terms of the three base or the fundamental physical quantities, mass, length, and time. However, in this system of units, every quantity can be expressed in terms of x. And we are given that the dimensions of different quantities in terms of x in this system are given as follows. So here we are given position to be x to the power a, we're given speed to be x to the power b, acceleration x to the power c, linear momentum x to the power f, and force is x to the power g. Alright. Then we are asked which of the following equations is or are correct. So look at these four equations given to you and you will see that these equations are in terms of the exponents of x. So you can see for yourself that a, b, c, d, D, f, and g. These are exponents of x for all these physical quantities given. So we need to see if these relationships between exponents, these are true or not, right? So what do you think you should do? Option A says b minus c equals f minus g. Alright, and we don't know if this is true, right? So we want to find out, is this true? How do you do that? Now, if I could show that x to the power b minus c equals x to the power f minus g, then in that case b minus c equals f minus g. How? Well, here in this equation where I wrote if statement, if x to the power b minus c equals x to the power f minus g. X is the base. If the base is same on either side of the equation, then the powers are also same. So let's now see if x to the power b minus c is indeed equal to x to the power f minus g. Because if that is true, then we know that b minus c is equal to f minus g. Alright, so let's start with this x to the power b minus c. Let's look at left hand side first. I'm going to solve left hand side and right hand side separately and then put them together to see if they are indeed equal to each other. Alright, I can write this as, put the square brackets to represent the dimensional formula. I can write this as x to the power b times x to the power minus c, the dimensional formula for these two, which can further be written as x to the power b times x to the power c, and I'm pulling this negative one out. Why? Because negative c is same as c times negative 1, and I pull this negative 1 out of the parentheses or the bracket. Okay, how else can I represent this now? I could write this as x to the power b's dimensional formula divided by x to the power c. Now let's see x to the power b divided by x to the power c. What are these quantities? We're given that x to the power b is speed and x to the power c is acceleration. Very well. So this is equal to speed divided by acceleration. Now at this point, you could go two ways. You could either solve this in terms of dimensions or you can solve this in terms of the SI units. Let's do with the dimensions first. Speed. What are the dimensions or the dimensional formula for speed? m0 L1 t minus 1. Likewise, acceleration is m0 L1 t minus 2. What does this give you? m0 divided by m0 remains m0. L1 divided by L1 becomes L0. t to the power minus 1 divided by t to the power minus 2 gives you t to the power 1. So we get x to the power b divided by x to the power c to be equal to m0 L0 t1. And x to the power b divided by x to the power c, this was actually equal to x to the power b minus c. So now we see that the x to the power b minus c, which is our left hand side of the equation A, of the option A, is equal to m0 L0 t1. So basically this has dimensions of what? Time. Why? Because, well, m0 and L0, they both have power of 0. Dimensions of time. Okay. Now let's move to the right hand side. What does right hand side say? Right hand side was x to the power f minus g. Alright. So let's write down x to the power f minus g. Square brackets to represent that we are dealing with the dimensional formula here. Just like we did for the left hand side, this will be equal to x to the power f times x to the power negative g, which can be further written as x to the power f times x to the power g and a negative sign, which can be written as x to the power f divided by x to the power g. Are you with me so far? Okay, now the right hand side now becomes equal to x to the power f divided by x to the power g. X to the power f is given to be equal to linear momentum, and x to the power g is force. Momentum is mass times velocity, so it becomes m1 L1 t minus 1. And force is mass times acceleration, m1 L1 t minus 2. So this will again give you dimensional formula for m0 L0 t1. I really did not need to go this far. Just from here where I say that linear momentum divided by force, I could write linear momentum equal to mass times velocity and force equal to mass times acceleration. And you see that the mass term or the factor cancels out and you're left with velocity over acceleration. And if you look on the left hand side, that was speed over acceleration. Now when you're talking about the dimensional formula, speed has the same dimensional formula as velocity. So we didn't really need to solve this much. We could have seen right here that the left hand side equals right hand side. I mean, as soon as you realize that left hand side is equal to, let's call speed as v, because we're really concerned with either the SI units or the dimensions. And for speed and velocity both, the dimensions and the SI units are identical. So this is velocity over acceleration, and right hand side is also velocity over acceleration after the masses cancel out on the right hand side here. So we see that now if we want to stick with the dimensional analysis, left hand side equals m0 L0 t1 and the right hand side equals m0 L0 t1 as well. So you see that option A, which was b minus c equals f minus g, this is true. Option A is correct. Do you see how I did it? All right. So let's move on to option B. If you missed to understand something in option A, option B's solution will make it clear. It is minus c plus f minus g equals b. Now, one difference between option A and option B is that in option A you had two terms on one side and two on the other side, while in option B I have three terms on one side and one on the other. If you wish, you could rearrange this equation to have two terms on one side and two on the other, or you could leave it as it is. It doesn't really matter. So how about we just follow the same procedure as we did in the first one, that is option A, and for that we have two terms on one side of the equation and two on the other side. And to do that, let me go ahead and add g on both sides of the equation. What would this give me? F minus c equals b plus g. Is this true? I do not know yet. Maybe it is true, maybe it isn't true. So let's do the same thing that we did before. We will raise x to the power f minus c on the left hand side and find out if that is equal to x to the power b plus g on the right hand side. Alright, here we go. Square brackets to represent that we are dealing with dimensions here. And we know that the left hand side can be written as x to the power f divided by x to the power c. And the right hand side though, that will have to be x to the power b times x to the power g. Why? Because we do not have any negative power on the right hand side. Now x to the power f, that is equal to linear momentum. And linear momentum is represented by letter P. Now you could use uppercase P or you could use lowercase p to represent momentum. Let me use lowercase p. So this lowercase p over here is momentum and x to the power c is acceleration a. I want to find out if this is equal to x to the power b is velocity or the speed times x to the power g, which was force F. Okay. Now let's see what can we do with this. P is mass times velocity divided by a. Is this equal to v times force? Force is mass times acceleration. Now if you look at this, we have mass on each side. So mass cancels out. In other words, if I divide both sides by m, mass will cancel out. Similarly, v is on both sides. So I'm going to divide both sides by v. This will cancel out our v's. What am I left with? 1 over a on the left hand side equals a on the right hand side. I mean, is this equal? So if you want to talk about the dimensionals formula for 1 over a and a, they will not be equal. Well, you can see for yourself. Dimensional formula for 1 over a will be m0 L minus 1 T2, while the dimensional formula for a will be m0 L1 T minus 2. If you want to check the SI units, then the SI unit for a is meters per second square, and SI unit for 1 over a will be second square over meter. And I'm sure you can see for yourself that meters per second square is not equal to second square over meter. So this option B is incorrect. No, it is not true. If you have any questions, please feel free to ask me in the comment section and I'll try my best to address your questions and concerns. So this was option B. Option B was incorrect. Option C says C minus F plus G equals B. So a very similar problem to option B. Let's go ahead and do the same thing as I did for option B. I'm going to subtract G on both sides. What does that give me? That gives me C minus F on the left hand side equals B minus G on the right hand side. Now should I be putting this equal sign? Well, I do not know. Is this true? Just like before, I'm going to raise x to the power c minus f on the left hand side and x to the power b minus g on the right hand side. And putting these parentheses or the square brackets around each side to represent that I'm dealing with dimensional formulae. Now left hand side will be x to the power c divided by x to the power f. And right hand side will be x to the power b divided by x to the power, g. Like this. X to the power c, it is acceleration. So let's see on the side here. X to the power c is acceleration. And x to the power f is momentum. X to the power b is speed, and x to the power g is force. And here, let me make this acceleration divided by mass times velocity equals velocity divided by force is mass times acceleration. Does anything cancel out? Yes, there's mass here, mass at the bottom here, mass at the bottom here. There's mass at the bottom of both sides. So if you multiply both sides by mass, m, these masses will cancel out. After that, there's nothing that cancels out. But you will get a squared equals v squared. Well, here. Is this true? Absolutely not. A squared is acceleration squared and v squared is speed squared. They're not equal to each other. So just right here, just say no. This option B, C is not true. I mean, I could have carried this further and solved it in terms of M, L, and T, but do I really need to? No, I do not need to. So option C is incorrect as well. Moving on to option D, which says A minus 2B minus C equals 0. Again, is this true? Now here, all the terms are on the left-hand side. Now again, if you wish, you could have two terms on one side, two on the other side. You could write this as A minus B minus C equals 0, which can be written as A minus B equals B plus C. And these equal signs, I do not know if this is true. Okay? But how about I just leave everything on the left-hand side and see where that takes me. So my left-hand side is A minus 2B minus C, and the right-hand side is 0. Let's raise this. Let's make this, whatever equation is given to us, let's make each side of that power of x. X to the power 0, it will give you simply m0, l0, t0. Or you could call this as 1. Okay? And left-hand side is not so simple, is it? We have x to the power a times x to the power minus 2b times x to the power minus c. Okay. How else can I write this? X to the power a times x to the power b to the power minus 1 times x to the power c to the power minus 1. And over here, I should have 2 inside the parentheses for the power. All right. Now, is this equal to 1? I do not know. Let's see. How else can I write left-hand side? X to the power a divided by x to the power 2b divided by x to the power c. Is this equal to 1? All right. Now, x to the power a is position. Let's use letter R for position. X to the power 2b, b is speed, v squared. X to the power c is acceleration, correct? Now, I didn't really need to write this, but I wrote it just to show it to you. Coming back to the left-hand side of the equation, we have x to the power a, which is position, m0, l1, t0. Then we have x to the power b to the power 2. So x to the power 2b can be written as x to the power b to the power 2. X to the power b is speed. Speed is m0 l1 t minus 1, and this is raised to the power 2. Next, I have this x to the power c in the denominator, which gives me acceleration m0 l1 t minus 2. We want to see if this is equal to what? If this is equal to 1, which is m0 l0 t0. All right, let's see. All right, let's look at the left-hand side. Numerator is m0 l1 t0, and all right, divided by, let's look at this first dimensional formula. This will give you m0 l2 t minus 2. Why? Because I brought this to inside the parentheses times this one over here, which is m0 L1 t minus 2. Is this equal to what? m0 L0 t0. Now, do I need to even solve this? Can you see that if these two sides are equal or not? Let's. All right. So m0 L1 t0 on the left hand side divided by m0 times m0 is m0. L2 times L1 is L3. T minus 2 times T minus 2 is T minus 4. Is this equal to M0 L0 T0? I'm carrying this forward just for completion. Now I'm pretty sure you can now see whether these two sides are equal or not. Anyway, left hand side becomes M0 divided by M0 is M0. L1 divided by L3 is L minus 2. T0 divided by T minus 4 is T4. And this is obviously not equal to M0 L0 T0. So our option D, which was A minus 2B minus C, is that equal to 0? No. This is not true. Now let me show you a different version of this. Let's make an option E and make that A minus 2B plus C. Is that equal to 0? Is this true? Okay. So we just saw that this should give us x to the power A divided by x to the power B 2, okay, times upstairs is x to the power C. Let me fix this a little bit at the bottom. Tell me if you see how I have written this. And we want to see that if this is equal to M0 L0 T0. Now x to the power A is position M0 L1 T0. X to the power C is acceleration M0 L1 T minus 2. And x to the power B is speed M0 L1 T minus 1 square. Is this equal to M0 L0 T0? Okay. Now on the left hand side, upstairs I have M0 L1 T0, and then I have M0 L1 T minus 2 divided by this 2 comes inside the brackets and gives us M0 L2 T minus 2. Is this equal to M0 L0 T0? What do you think? Let's see. M0 times M0 gives me M0. L1 times L1 gives me L2. T0 times T minus 2 gives me T minus 2. And what do I divide this by? M0 L2 T minus 2. What do you think this will give me? Yes, this will give me M0 L0 T0. So this option E that I just made up, yes, this is true. How did you like this problem? I think this was a really fun problem. It was a little different. I mean, you were dealing with the powers of the variable here, and the equations, the options given to you were in terms of those powers, right? So I think this was a pretty interesting problem, very instructive problem. Hopefully it made sense to you. And like I always keep saying, if there is any question, there's something that you do not understand, please do not hesitate to ask me in the comments. I will do my best to address any concerns and questions of you on the subject matter. And one thing again, if you want to be proficient in physics or in any kind of science for that matter, especially physical sciences, there's only one way, and that is practice. So when you see somebody else solving problems, it looks easy. Things look easier when somebody else is doing it, and they're not so easy when you're doing it. However, this is a skill set, this is a mindset that you can develop by practicing. So do not just watch me solve problems, do not watch somebody else solve problems. I mean, do not just watch. It's okay to watch, but if you do nothing after that, it's not going to help you very much. So I strongly recommend that now that you have seen this problem, how it is solved, If you haven't already done that, take out a piece of paper and pencil and solve this problem on your own and see that you can do it on your own. Alrighty, with this, let's move on to problem number 2 for this lecture. Problem number 2. What would be the dimensions of mass in a system where time, velocity, and momentum are considered as the fundamental quantities? Now, in this lecture series, you have seen problems like this a few times before, where you're given that instead of mass, length, and time, you have some different quantities as the fundamental quantities. And those options could be like speed of light, Planck's constant, and gravitational constant. Very popular choice. And in this problem, we're given that instead of mass, length, and time, you have time, velocity, and momentum as the fundamental quantities. And you're asked to solve for dimensions of mass in terms of time, velocity, and momentum. Now you'd know that the mass in terms of mass, length, and time is m1, l0, t0. We know this. But here we are told that this mass, it is proportional to what? Time t, velocity v, and momentum p. And these powers are a, b, and c. So if we could determine this a, b, and c, we have cracked the problem. That's all we are asked to solve for. So in all such problems, what you do, you remove the symbol of proportionality and you introduce a constant k. And this constant k is a dimensionless constant. Now in the previous problem, I have shown you how to solve it using dimensional analysis. Let's try it a different way this time. Let's solve this using SI units. Alright, SI units for mass, kilograms. SI units for K, nothing. Why? Because it's dimensionless constant. Moving on to time t, seconds to the power a. Next, for velocity, we have SI units of meters per second. And this will be raised to the power b, this b over here. And last is momentum. Momentum is mass times velocity. So the SI units for momentum are kilograms times meters per second. And these units will be raised to the power c. Why? Because momentum p is raised to the power c. Let's see what we get now on the right hand side. We get seconds to the power a, meters to the power b, divided by seconds to the power b, times kilograms to the power c, times meters to the power c, divided by seconds to the power c. Alrighty, now let's combine like SI units on the right hand side. That means I have kilograms to the power c. Why? Because there is no other unit of kilograms on the right hand side. Moving on to meters. I have meters to the power b times meters to the power c. So that would give me meters to the power b plus c. Moving on to seconds. Seconds to the power a. Seconds to the power b is downstairs, so this will give me minus b upstairs. Seconds to the power c downstairs will come upstairs and become minus c. And I have kilograms on the left hand side. Next, I'm going to compare kilogram on the left hand side to kilograms on the right hand side. So kilograms to the power 1 equals kilograms to the power c. Next, if you look on the left hand side, you do not have any factor of meters, so I can put meters to the power 0 on the left hand side. Why? Because anything to the power 0 is 1. That gives me meter to the power 0 on the left hand side equals meter to the power b plus c on the right hand side. Moving on to seconds. Again, there is no factor of seconds on the left hand side, so I'll insert seconds to the power 0. That gives me second to the power 0 equals seconds to the power a minus b minus c on the right hand side. Let's look at the equation for kilograms. That gives me c equals 1. And Moving on to meter to the power 0 equals meter to the power b plus c. That will give me b plus c is equal to 0, which implies b is equal to negative c, means minus 1. So here we have solved for b and c now. Last equation will give you a minus b minus c equals 0. Now already know b and c. Rearranging this equation gives you a equals b plus c. Now b is equal to minus 1, c is plus 1, so a is equal to 0. Interesting. So what did I get? I get a is equal to 0, b is equal to minus 1, c is equal to 1. What was our equation? We were given that mass is proportional to time, velocity, and momentum. And the powers given were a, b, and c. So now t to the power a becomes t to the power 0. V to the power b is v to the power negative 1 and p to the power plus 1 for c. And here on the left hand side I have mass. So that would give me m is proportional to p over v. Now think about this. P, the momentum, is equal to mass times velocity. So if I divide it by velocity, what am I left with? Mass. Here, mass. So I can write this equation as mass equals some dimensionless constant times p over v, which makes sense, doesn't it? All right. So this was our problem number 2. This lecture will have 2 problems, and the next lecture, which will be the last lecture of the dimensional analysis, will have a few more problems that are going to be extremely constructive and instructive problems for you guys. And that lecture will be coming out very soon. All right. I hope that you found this lecture useful, and if you think that it is useful to you, then just to motivate me, I'll really appreciate if you will subscribe to the channel and like this video. This is my evening and weekend job, and it will be nice to have some motivation, some more motivation to do it. I'm quite intrinsically motivated, but extrinsic motivation will be good too. All right, you all have a good one. I'll see you again very soon.